Hi, this is Rob Sheen from the Source Conference, and I'm here with Michael Borohovski, who's the CTO of Tinfoil Security, and he's going to be speaking at Source Austin on December 5th and 6th, and his talk is on API security scanning. How do you do it right? So, Michael, thanks for joining us. And what kind of APIs are we talking about, first of all?
It's a good question, Rob. In fact, we get that question a lot, right? Because API is actually an overloaded term. Once upon a time, right, decades ago, it meant basically an SDK that you were using to build an application for an actual desktop device. Nowadays, what we're referring to is really anything that's internet connected, but doesn't have a browsable web interface. Services that back mobile applications, even things that back web applications. People call them web services or web APIs, or things that back devices, right? Fitbits, windmills, etc. Anything that talks to the internet, but not kind of in the traditional web application sense. And so usually these are RESTful APIs, but you'll find them in the form of SOAP and things like that as well, or even custom RPC calls and things like that too.
Got it. So, how are you going about scanning them? Do you have your own custom tools, or are you using off-the-shelf stuff? What are you kind of doing here?
It's another great question. So we thought about this for a while, right? We thought about, do we build a custom tool? Do we try to figure out, how to jerry-rig a web application scanner to work with APIs? Do we, use something open source, et cetera? We ended up building something completely from scratch and from the ground up. And the reason is because APIs are fundamentally a different beast from web application scanning, right? We already had a great web application scanner that can crawl applications and look for vulnerabilities and so on and so forth. It works really well, but it's fairly resource intensive because browsers take a lot of time to spin up and to interact with and so on. People do crazy things with JavaScript nowadays and so on and so forth. APIs are kind of a different beast altogether, right? So the way that we scan APIs, and frankly the way that we think they should be scanned, is first and foremost we solve the crawlability problem by ingesting documentation, right? We think all APIs should be documented, and if they aren't, that's step number one. If you don't know what your API is supposed to be doing, you're in for a world of trouble before you've even thought about looking for security vulnerabilities, right? But having the API documentation, again, typically in the form of Swagger or the Open API specification, but also, people sometimes use RAML and API Blueprint and things like that. What ingesting that does for us is allows us to build a map of the API and of all of the endpoints and of all the parameters and of all the constraints on those parameters and so on and so forth down the list. Doing that allows us to understand how to sign requests, allows us to understand what the expectations for each parameter is supposed to be. So we can do things like start intelligently fuzzing the actual parameters themselves, right? If we know it's supposed to be an integer between 12 and 15, we're going to start looking to see what happens if it's 11, what happens if it's 16 and 10,000 and so forth, right? Gives us a lot more knowledge to be able to do more intelligent testing of the actual API itself. We also, the other important aspect to APIs as compared to web applications is that while both support authentication, the constraints on authentication are fundamentally different, right? APIs have vastly more different ways to authenticate than web applications do. Web applications kind of boil down to two things, right? Either it authenticates with cookies at the end of the day or local storage. Occasionally you'll see things that are gated on IP and things like that, but really don't recommend it. For APIs though, it varies, right? You can authenticate with query parameters, you can authenticate with headers, you can authenticate with OAuth and all the different, credential types for OAuth, you can, and so on and so forth down the list. So what we've done is actually pretty interesting, which is we kind of think of authenticators as Lego bricks that we can stack one on top of the other and apply in order to any individual request, which allows us to then, be able to stay authenticated and keep an authenticated session, refresh tokens, and so forth. Also allows us to audit the authentication, which then leads to the next really interesting aspect of things like authorization bypass, right? So using a vendor extension for Swagger, we can specify, which endpoints and which parameters should have access or should be able to be accessed by a particular user or role. And then we can definitely do things like look for authorization bypasses where one user that shouldn't have access does, and vice versa.
Cool. So you're able to actually, I'm assuming this is kind of designed for like informed penetration tests where you are working with the customer and are able to get legitimate credentials. So that way you can test deeper into the API than you would be able to just scan on the outside without being able to log in, right?
Yeah, kind of. So, I mean, we have some people that are using it for, yeah, exactly that, right? Kind of informed penetration tests. Others where developers are using it just as a, as part of the SDLC to try and figure out if there are vulnerabilities in the applications they're writing. But yeah, in any case, valid credentials would be required in order to be able to actually do a scan of the internals of the application. Most APIs and applications nowadays don't really have anything interesting or as much interesting on the outside. APIs in particular don't really tend to do very much that's interesting without authentication, unless they're kind of a read-only grab data from the web API, right?
Or built by people that haven't quite come to terms with security yet.
Or that, yeah.
There's definitely still some of that out there.
Yeah.
So it sounds like you're just...
Perhaps I should say that APIs don't normally intentionally do anything interesting without authentication.
So it sounds like you're doing a combination of discovery and active probing once you've kind of figured out what the API is supposed to do.
Yeah. So we kind of get around the discovery problem a bit through the documentation. One thing we are going to eventually work on is some sort of proxy thing that will listen for traffic and touch up the documentation as needed. So we'll actually be able to make the documentation even more correct, at least based on the actual variability of what we're seeing in the API. But it's not something we have right now, right? So we kind of worked around the crawlability problem or the discovery problem today by using the documentation that development teams tend to usually already have. And if they don't have that, I mean, that's the first thing we recommend for kind of a good process towards security. We can sit here and build an API application firewall or whatever, and try to drop requests that look malicious and things like that. But at the end of the day, if you don't know what your API is supposed to be doing, you'll never know if it's doing that correctly.
Right. So, the title of your talk is API security scanning. How do you do it right?
Yeah.
So presumably that means you probably think that some people are doing it wrong. So what are some ways that people have gotten it wrong in the past?
Yeah. So, you're right. We do think a lot of people are doing it wrong. The vast majority of what people are doing for API scanning, boils down to one or two things. Well, a few things actually. One is a lot of times, honestly, they're just relying on kind of best practices checklists, and hoping that their developers, follow these rules. That's cool and all, but that doesn't work for very long, especially as your development team grows. Another common, mistake that people make is that they fail to see that APIs are a fundamentally different beast from web applications and thus require a different form of scanning, right? So they'll take their web application scanner, they'll throw it against an API, and start looking for web application type vulnerabilities in an API. That's not to say they can't be found, right? So we look for XSS and SQLite and things like that in APIs as well. But it's different, right? APIs don't speak HTML. They don't speak JavaScript. They speak JSON, XML, and so forth. It's not going to get you very far if you take a web application scanner and just kind of throw it against an API, right? And last but not least, the other big thing that people do is they fail to see that not only is authentication important, but doing kind of intelligent fuzzing of an API is really important too, right? Sometimes people will fail to understand how to sign requests. They kind of see APIs as more of a black box. You can absolutely do black box fuzzing of an API, and I would argue that that's what we do, right? We don't actually look at the source code. We just do informed black box fuzzing.
Mm-hmm. Got it. So, what are the kinds of things that you typically find lately when you're scanning APIs?
Yeah, so it varies, right? So we'll find things like SQL injection occasionally, or NoSQL injection and so forth. We have actually occasionally found XSS, and the way it manifests is kind of interesting, right? So if the injection that you put into the data comes back looking like it's part of an HTML or XML document, and you don't have, for example, an XContent type options header set, sending that to a user will actually XSS them on your domain, which was clearly not your intent. And so, we'll do things like look for appropriate headers, like X content type options, and so forth. But we'll also do things that, like I said, like look for authentication leakage and authorization bypass, and so on and so forth.
Okay. Any big gotchas that developers should be paying attention to as they're writing APIs that you've noticed?
Yeah, document everything, right? That would be again my first recommendation. Not just because whatever, that's what we need, but because I truly believe if you don't know what it's supposed to do, you'll never. Okay, so if we look at it kind of a little bit more abstractly, I'm of the belief, I've been doing vulnerability assessment and exploit development and exploit weaponization for a long time, and I'm of the belief, and I don't think anybody would disagree, that vulnerabilities effectively come from unintended and undocumented behavior, right? Things that a developer didn't intend to have occur. If you don't know what your API is supposed to do in the first place, and you don't have documentation for that, you'll never know if something was intended or not, right? Was this consequence something that you intended to happen? Not, you won't have any idea. And so one of the things that we think is important is fixing all of those situations in which the implementation doesn't match the specification, because it gives an attacker a lot less surface area to mess with, right? So that would be my biggest thing, is make sure the implementation matches the spec, and the best way to do that is document.
Cool. All right. Well, look forward to hearing more about this at Source. And so again, Michael's going to be speaking at Source Austin on December 5th and 6th. And if you want to continue the conversation with him on API security, definitely stop by Source Austin and check it out.
Awesome. Thanks, Rob.
Thanks a lot, man.